construct a binary search tree inserting 8, 6, 12, 3, 10, 9, one after another. To make the resulting tree as AVL tree, which of the following is required? Option A, one right rotation only. Option B, one left rotation followed by two right rotations. Option C, one left rotation and one right rotation. Option D, the resulting tree is AVL tree. First of all, we have to find out the binary search tree for the nodes given. First, we have to take 8, the same order. Normally, the binary search tree, if the value is less, we will put it on the left side. If the value is more than the node, we will put it on the right side. Okay. Now, first we take 8 in the same order we have to take. That is what mentioned. If we take 8, the next value to be inserted is 6. 6 will go to left side because it is less than 8. Then the next value is 12 in the given sequence. So it will go to right side. That means 12 we have to insert here. Again 3. It is less than the 8, then less than 6, so that it will go to the left child of 6. Again 10, it is more than 8, and then less than 12, it is going to the left child of 12. Okay, again we are having 9. 9 is greater than 8 and less than 12, then it will go to the right child of, this is less than 10, so it will go to the left child of 10. So now this is which you have to find out. This is the binary search tree, but to make the resulting tree as AVL tree, but this is not AVL tree. AVL tree means, for example, if you take at any node, the balance factor should be either plus or minus 1 or 0. That means for 8, this every node should satisfy the balance factor. The left subtree height is 2, right subtree height is 3. That is 1. Okay. For 8 it is satisfied. Like that every node should satisfy. So now 6, this left subtree is 1, right subtree is 0, it is satisfied. And for 12, left subtree is 2, right subtree is 0. The difference is 2. It won't allow. The difference either plus or minus 1 or 0 will be allowed at every node. So if you want to make this as AVL tree, we have to do some operation, some rotation operation. For example, if you do one rotation, something like 10 will come here, 12 will come here, 9 will come here, and the resulting will satisfy the binary search property. So 8 is here, 6 is here, and 3 is here. Whatever we are rotating is, we are rotating these 3 in one position, so that the 10 will come here, 12 will go here, and the 9 will come here. So now it is an AVL tree. For 8, left subtree length is 2, right subtree length is also 2. For 6, left subtree 1, right subtree 0. 1 minus 0, difference is 1. Difference 1 is okay. For 10, left subtree 1, right subtree 1, and it satisfies the binary search tree property. That is, left side should be less value, right side should be more value. And then if you take 9, both are 0. For 12, both are 0. So all are satisfying the AVL property, that is height balanced. So that means we are having one rotation. With one rotation, we can get the AVL tree for the given binary search tree. Still, it does not lose any property of binary search tree. So that option A is the right option.
A program is given, and in that program we have to find how many times this particular statement is executed. So if we take n is equal to 1, if we take n is equal to 1, here I is less than 1, as I is equal to 0. When n is equal to 1, here this in this for loop I is equal to 0, I is less than 1. So this condition is true, and it will go to this loop. Here for j is equal to 0, j is less than I. Here I is 0, so j is less than 0. This is false, so this will not go into the for loop. So we can say for n is equal to 1, x gets executed only, sorry, x will not be executed. So for n is equal to 1, it is x is going to be executed, x is not going to be executed. So here we will write 0. Let us check for n is equal to 2. If n is equal to 2, here this condition is satisfied, so it will go to inner loop. Here j is equal to 0. For j is equal to here first, as n is 2 and as I is 0, this will be for the first time, it will not this condition will be failed. So here, as it will come, this control will come here, as this is in the for loop, the outer for loop. Here I value is incremented, I value will become 1. So here I is less than 2, 1 is less than 2, so this is satisfied. Here j is equal to 0, here j is less than, here now I value is 1, so here this condition will be satisfied. So here this x statement x would be executed once. If when j value is increased, this condition will be failed. So here control will come here, again I value will be increased. Now I value will become 2, as 2 is less than 2, this is false. So this will, when n is equal to, x will be executed only once. Let us check if when n is equal to 3. If n is equal to 3, it will be executed 1 plus 2. So for n is equal to 0, for n is equal to 0, sorry, for n is equal to 1, it is executed 0 times. For n is equal to 2, it is executed 1 time. For n is equal to 3, it is executed 1 plus 2. So if we generalize this, it is executed like 1 plus 2, so on up to n minus 1. So these many times it is executed. So this is nothing but sigma n minus 1. Sigma n minus 1 is nothing but n into n minus 1 by 2. Or else we can substitute in the options. For n is equal to 1, we are getting it is 0 times. So this will not be, this will be failed. Even this will be failed. N is equal to 1, it will become 1. So this is false. So let us substitute here. N is equal to 1, 1 into 0 by 2. So this, so we can say option C is correct. You can generalize like this, or you can substitute in the options. So here correct option is option C.